Number 2, 4x squared plus 2x plus 2 equals 0. Let's see, it's already set to 0, so I can look at it as ax squared plus bx plus c equals 0. My a is going to be a positive 4, b is a positive 2, and c is a positive 2. No negatives to worry about on this problem. X is equal to negative b, which is a 2, plus or minus, square root 2 squared minus 4 times a, which is 4, times c, which is 2, all over 2 times 4. And then I get negative 2 plus or minus, 2 squared is 4. Negative 4 times positive 4 would be negative 16. Negative 16 times 2 is going to be negative 32 all over 8. 4 minus 32, that's going to give me a negative 28. And negative 2 plus or minus over 8. Now, negative 28, I'm thinking, is going to give me a complex number because there's a negative under. I should think of it as the square root of negative 1 times the square root of 28. And then I'm looking at 28. I know that's 4 times 7, and 4 is a perfect square. It's 2 times 2. So that part, the 2 times 2, is going to come out. So I can rewrite it. I have the square root of negative 1 times the square root of 4 times the square root of 7. And don't forget, the square root of negative 1 is I. The square root of 4 is 2, so I'll put that at the front. And then square root of 7, I can't do anything with. I'm stuck with it. So there's my simplified radical for the square root of negative 28. So I can rewrite, I have negative 2 plus or minus 2i square root of 7 over, I want to think about this and separate it maybe, because I know I can reduce if I put each over 8. So let's do that. So I break it apart and put the 8 as a denominator for each of my two fractions. Now I can reduce. 2 divided by 2 is 1, 8 divided by 2 is 4, 2 divided by 2 is 1, 8 divided by 2 is 4. And finally, I can write my answers. X is equal to 1/4, or it's negative 1/4, plus I square root of 7 over 4. That's one answer. My second answer, negative 1/4 minus I square root of 7 over 4. So two different answers. I did need complex numbers, and I was able to reduce the two fractions at the end.